3 are some other points of interest in the sample request. The referrer header is used to indicate the URL from which the request originated, for example, because the user clicked the link on that page. Note that this header was misspelled in the original HTTP specify cation, and the misspelled version has been retained ever since. The user agent header is used to provide information about the browser or other client software that generated the request. Note that most browsers include the Mozilla Prefix X for historical reasons. This was the user agent string used by the originally dominant Netscape browser, and other browsers wanted to assert to websites that they were compatible with this standard. As with many quirks from computing history, it has become so established that it is still retained, even on the current version of Internet Explorer, which made the request shown in the example. The host header specify the hostname that appeared in the full URL being accessed. This is necessary when multiple websites are hosted on the same server, because the URL sent in the FI-RST line of the request usually does not contain a hostname. See Chapter 17 for more information about virtually hosted websites. The cookie header is used to submit additional parameters that the server has issued to the client, described in more detail later in this chapter. HTTP responses. A typical HTTP response is as follows. HTTP/1.1200 OK date, Tuesday, April 19, 2011, 9:23 and 32 seconds Greenwich Mean Time Server, Microsoft IIS/6.0x powered by ASP.NET Set Cookie. Tracking equals TIARK7JOMX44S2U85NSWC XASP.NET version 2.0.50727 cache control. No cache pragma. No cache expires. Thursday, January 1st, 1970, 0 o'clock Greenwich Mean Time content type. Text/HTML. Char set equals UTF, 8 content length, 1067. Doc type HTML public //W3C//DTDX HTML 1.0 transitional //en. http://www.w3.org/tr/xhtml1/DTD/xhtml1-transitional.ttd/HTML XMLNS equals http://www.w3.org/199/xhtml head title your details/title. 42. Chapter 3 Web Application Technologies. The FI-RST line of every HTTP response consists of 3 items separated by spaces. The HTTP version being used. A numeric status code indicating the result of the request. 200 is the most common status code. It means that the request was successful in that the requested resource is being returned. A textual reason phrase further describing the status of the response. This can have any value and is not used for any purpose by current browsers. Here are some other points of interest in the response. The server header contains a banner indicating the web server software being used, and sometimes other details such as installed modules and the server operating system. The information contained may or may not be accurate. The set cookie header issues the browser a further cookie. This is submitted back in the cookie header of subsequent requests to the server. The pragma header instructs the browser not to store the response in its cache. The expires header indicates that the response content expired in the past and therefore should not be cached. These instructions are frequently issued when dynamic content is being returned to ensure that browsers obtain a fresh version of this content on subsequent occasions. Almost all HTTP responses contain a message body following a blank line after the headers. The content type header indicates that the body of this message contains an HTML document. The content length header indicates the length of the message body in bytes. HTTP methods. When you are attacking web applications, you will be dealing almost exclusively with the most commonly used methods, get and post. You need to be aware of some important differences between these methods as they can affect an application security if overlooked. The get method is designed to retrieve resources. It can be used to send parameters to the requested resource in the URL query string. This enables users to bookmark a URL for a dynamic resource that they can reuse, or other users can retrieve the equivalent resource on a subsequent occasion, as in a bookmark search query. URLs are displayed on screen and are logged in various places such as the browser history and the web server's access logs. They are also transmitted in the referrer header to other sites when external. Chapter 3 Web Application Technologies. 43. Links are followed. For these reasons, the query string should not be used to transmit any sensitive information. The post method is designed to perform actions. With this method, request parameters can be sent both in the URL query string and in the body of the message. Although the URL can still be bookmarked, any parameters sent in the message body will be excluded from the bookmark. These parameters will also be excluded from the various locations in which logs of URLs are maintained and from the referrer header. Because the post method is designed for performing actions, if a user clicks the browser's back button to return to a page that was accessed using this method, the browser does not automatically reissue the request. Instead, it warns the user of what it is about to do, as shown in Figure 3.1. This prevents users from unwittingly performing an action more than once. For this reason, post request should always be used when an action is being performed. Figure 3.1. Browsers do not automatically reissue post requests made by users because these might cause an action to be performed more than once. In addition to the GET and post methods, the HTTP protocol supports numerous other methods that have been created for specify C purposes. Here are the other ones you are most likely to require knowledge of. Head functions in the same way as a GET request, except that the server should not return a message body in its response. The server should return the same headers that it would have returned to the corresponding GET request. Hence, this method can be used to check whether a resource is present before making a GET request for it. Trace is designed for diagnostic purposes. The server should return in the response body the exact contents of the request message it received. This can be used to detect the effect of any proxy servers between the client and server that may manipulate the request. Options ask the server to report the HTTP methods that are available for a particular resource. The server typically returns a response containing an allow header that lists the available methods. Put attempts to upload the specified resource to the server using the content contained in the body of the request. If this method is enabled, you may be able to leverage it to attack the application, such as by uploading an arbitrary script and executing it on the server. 44. Chapter 3 Web Application Technologies. Many other HTTP methods exist that are not directly relevant to attacking web applications. However, a web server may expose itself to attack if certain dangerous methods are available. See Chapter 18 for further details on these methods and examples of using them in an attack. URLs. A uniform resource locator, URL, is a unique identifier for a web resource through which that resource can be retrieved. The format of most URLs is as follows. Protocol, //hostname, port, /path, file, param equals value. Several components in this scheme are optional. The port number usually is included only if it differs from the default used by the relevant protocol. The URL used to generate the HTTP request shown earlier is as follows. https://mdsec.net/auth/488/yourdetails.hx?UID = *129. In addition to this absolute form, URLs may be specified relative to a particular host or relative to a particular path on that host. For example, /auth/488/yourdetails.asks, UID equals 129 yourdetails.asks, UID equals 129. These relative forms are often used in web pages to describe navigation within the website or application itself. Note you may encounter the term URI or Uniform Resource Identifier being used instead of URL, but it is really only used in formal specified cations and by those who want to exhibit their pedantry. REST. Representational State Transfer, REST, is a style of architecture for distributed systems in which requests and responses contain representations of the current state of the system's resources. The core technologies employed in the World Wide Web, including the HTTP protocol and the format of URLs, conform to the REST architectural style. Although URLs containing parameters within the query string do themselves conform to REST constraints, the term REST style URL is often used to signify a URL that contains its parameters within the URL file path rather than the query string. For example, the following URL containing a query string http://what-app.com/search?make $forward$model=Pinto corresponds to the following URL containing REST style parameters http://what-app.com/search/forward/Pinto. Chapter 3 Web Application Technologies. 45. Chapter 4 describes how you need to consider these different parameter styles when mapping an application's content and functionality and identifying its key attack surface. HTTP headers. HTTP supports a large number of headers, some of which are designed for specify C unusual purposes. Some headers can be used for both requests and responses, and others are specify C to one of these message types. The following sections describe the headers you are likely to encounter when attacking web applications. General headers. Connection tells the other end of the communication whether it should close the TCP connection after the HTTP transmission has completed or keep it open for further messages. Content encoding specify ES what kind of encoding is being used for the content contained in the message body, such as gzip, which is used by some applications to compress responses for faster transmission. Content length specify ES the length of the message body in bytes, except in the case of responses to HEAD requests, when it indicates the length of the body in the response to the corresponding GET request. Content type specify ES the type of content contained in the message body, such as text/HTML for HTML documents. Transfer encoding specify ES any encoding that was performed on the message body to facilitate its transfer over HTTP. It is normally used to specify chunked encoding when this is employed. Request headers. Accept tells the server what kinds of content the client is willing to accept, such as image types, OFFIC document formats, and so on. Accept encoding tells the server what kinds of content encoding the client is willing to accept. Authorization submits credentials to the server for one of the built-in HTTP authentication types. Cookie submits cookies to the server that the server previously issued. Host specify ES the hostname that appeared in the full URL being requested. 46. Chapter 3 Web Application Technologies. If modified since specify ES when the browser last received the requested resource. If the resource has not changed since that time, the server may instruct the client to use its cache copy, using a response with status code 304. If none match specify ES an entity tag, which is an identifier denoting the contents of the message body. The browser submits the entity tag that the server issued with the requested resource when it was last received. The server can use the entity tag to determine whether the browser may use its cache copy of the resource. Origin is used in cross-domain AJAX requests to indicate the domain from which the request originated. See Chapter 13. Refer specify ES the URL from which the current request originated. User agent provides information about the browser or other client software that generated the request. Response headers. Access control allow origin indicates whether the resource can be retrieved via cross-domain AJAX requests. See Chapter 13. Cache control passes caching directives to the browser, for example, no cache. E-tag specify ES an entity tag. Clients can submit this identifier in future requests for the same resource in the if none match header to notify the server which version of the resource the browser currently holds in its cache. Expires tells the browser for how long the contents of the message body are valid. The browser may use the cache copy of this resource until this time. Location is used in redirection responses, those that have a status code starting with 3, to specify the target of the redirect. Pragma passes caching directives to the browser, for example, no cache. Server provides information about the web server software being used. Set cookie issues cookies to the browser that it will submit back to the server in subsequent requests. www authenticate is used in responses that have a 401 status code to provide details on the types of authentication that the server supports. X-frame options indicates whether and how the current response may be loaded within a browser frame. See Chapter 13. Chapter 3 Web Application Technologies. 47. Cookies. Cookies are a key part of the HTTP protocol that most web applications rely on. Frequently they can be used as a vehicle for exploiting vulnerabilities. The cookie mechanism enables the server to send items of data to the client, which the client stores and resubmits to the server. Unlike the other types of request parameters, those within the URL query string or the message body, cookies continue to be resubmitted in each subsequent request without any particular action required by the application or the user. A server issues a cookie using the set cookie response header as you have seen. Set cookie, tracking equals TI8RK7JOMX44S2U85NSWC. The user's browser then automatically adds the following header to subsequent requests back to the same server. Cookie, tracking equals TI8RK7JOMX44S2U85NSWC. Cookies normally consist of a name/value pair as shown, but they may consist of any string that does not contain a space. Multiple cookies can be issued by using multiple set cookie headers in the server's response. These are submitted back to the server in the same cookie header with a semicolon separating different individual cookies. In addition to the cookie's actual value, the set cookie header can include any of the following optional attributes, which can be used to control how the browser handles the cookie. Expire sets a date until which the cookie is valid. This causes the browser to save the cookie to persistent storage, and it is reused in subsequent browser sessions until the expiration date is reached. If this attribute is not set, the cookie is used only in the current browser session. Domain specify ES the domain for which the cookie is valid. This must be the same or parent of the domain from which the cookie is received. Path specify ES the URL path for which the cookie is valid. Secure, if this attribute is set, the cookie will be submitted only in HTTPS requests. HTTP only, if this attribute is set, the cookie cannot be directly accessed via client-side JavaScript. Each of these cookie attributes can impact the application's security. The primary impact is on the attacker's ability to directly target other users of the application. See Chapters 12 and 13 for more details. 48. Chapter 3 Web Application Technologies. Status codes. Each HTTP response message must contain a status code in its FI RST line indicating the result of the request. The status codes fall into 5 EE groups according to the code's FI RST digit. 1XX informational. 2XX the request was successful. 3XX the client is redirected to a different resource. 4XX the request contains an error of some kind. 5xx the server encountered an error fulfilling the request. There are numerous specify C status codes, many of which are used only in specialized circumstances. Here are the status codes you are most likely to encounter when attacking a web application, along with the usual reason phrase associated with them. 100 continue is sent in some circumstances when a client submits a request containing a body. The response indicates that the request headers were received and that the client should continue sending the body. The server returns a second response when the request has been completed. 200 OK indicates that the request was successful and that the response body contains the result of the request. 201 created is returned in response to a put request to indicate that the request was successful. 301 moved permanently redirects the browser permanently to a different URL, which is specified in the location header. The client should use the new URL in the future rather than the original. 302 found redirects the browser temporarily to a different URL, which is specified in the location header. The client should revert to the original URL in subsequent requests. 304 not modified instructs the browser to use its cache copy of the requested resource. The server uses the if modified since and if none match request headers to determine whether the client has the latest version of the resource. 400 bad request indicates that the client submitted an invalid HTTP request. You will probably encounter this when you have modify at a request in certain invalid ways, such as by placing a space character into the URL. 401 unauthorized indicates that the server requires HTTP authentication before the request will be granted. The www authenticate header contains details on the types of authentication supported. Chapter 3 Web Application Technologies. 49. 403 forbidden indicates that no one is allowed to access the requested resource, regardless of authentication. 404 not found indicates that the requested resource does not exist. 405 method not allowed indicates that the method used in the request is not supported for the specify at URL. For example, you may receive the status code if you attempt to use the put method where it is not supported. 413 request entity too large. If you are probing for buffer overflow vulnerabilities in native code and therefore are submitting long strings of data, this indicates that the body of your request is too large for the server to handle. 414 request URI too long is similar to the 413 response. It indicates that the URL used in the request is too large for the server to handle. 500 internal server error indicates that the server encountered an error fulfilling the request. This normally occurs when you have submitted unexpected input that caused an unhandled error somewhere within the application's processing. You should closely review the full contents of the server's response for any details indicating the nature of the error. 503 service unavailable normally indicates that, although the web server itself is functioning and can respond to requests, the application accessed via the server is not responding. You should verify whether this is the result of any action you have performed. HTTPS. The HTTP protocol uses plain TCP as its transport mechanism, which is unencrypted and therefore can be intercepted by an attacker who is suitably posy. Tioned on the network. HTTPS is essentially the same application layer protocol as HTTP but is tunneled over the secure transport mechanism, secure sockets layer SSL. This protects the privacy and integrity of data passing over the network, reducing the possibilities for non-invasive interception attacks. HTTP. Requests and responses function in exactly the same way regardless of whether SSL is used for transport. Note SSL has strictly been superseded by Transport Layer Security TLS, but the latter usually still is referred to using the older name. HTTP proxies. An HTTP proxy is a server that mediates access between the client browser and the destination web server when a browser has been configured to use a proxy. 50. Chapter 3 Web Application Technologies. Server it makes all its requests to that server. The proxy relays the requests to the relevant web servers and forwards their responses back to the browser. Most proxies also provide additional services including caching, authentication, and access control. You should be aware of two differences in how HTTP works when a proxy server is being used. When a browser issues an unencrypted HTTP request to a proxy server, it places the full URL into the request, including the protocol prefix http:// the server's hostname, and the port number if this is non-standard. The proxy server extracts the hostname and port and uses these to direct the request to the correct destination web server. When HTTPS is being used, the browser cannot perform the SSL handshake with the proxy server because this would break the secure tunnel and leave the communications vulnerable to interception attacks. Hence, the browser must use the proxy as a pure TCP level relay which passes all network data in both directions between the browser and the destination web server with which the browser performs an SSL handshake as normal. To establish this relay, the browser makes an HTTP request to the proxy server using the connect method and specifying the destination hostname and port number as the URL. If the proxy allows the request, it returns an HTTP response with a 200 status, keeps the TCP connection open, and from that point onward acts as a pure TCP level relay to the destination web server. By some measure, the most useful item in your toolkit when attacking web applications is a specialized kind of proxy server that sits between your browser and the target website and allows you to intercept and modify all requests and responses, even those using HTTPS. We will begin examining how you can use this kind of tool in the next chapter. HTTP authentication. The HTTP protocol includes its own mechanisms for authenticating users using various authentication schemes, including the following. Basic is a simple authentication mechanism that sends user credentials as a base64 encoded string in a request header with each message. NTLM is a challenge response mechanism and uses a version of the Windows NTLM protocol. Digest is a challenge response mechanism and uses MD5 checksums of a nonce with the user's credentials. Chapter 3 Web Application Technologies. 51. It is relatively rare to encounter these authentication protocols being used by web applications deployed on the internet. They are more commonly used within organizations to access internet-based services. Common myth. Basic authentication is insecure. Because basic authentication places credentials in unencrypted form within the HTTP request, it is frequently stated that the protocol is insecure and should not be used. But forms-based authentication, as used by numerous banks, also places credentials in unencrypted form within the HTTP request. Any HTTP message can be protected from eavesdropping attacks by using HTTPS as a transport mechanism, which should be done by every security-conscious application. In relation to eavesdropping at least, basic authentication in itself is no worse than the methods used by the majority of today's web applications. Web functionality. In addition to the core communications protocol used to send messages between client and server, web applications employ numerous technologies to deliver their functionality. Any reasonably functional application may employ dozens of distinct technologies within its server and client components. Before you can mount a serious attack against a web application, you need a basic understand of how its functionality is implemented, how the technologies used are designed to behave, and where their weak points are likely to lie. Server-side functionality. The early World Wide Web contained entirely static content. Websites consist of various resources such as HTML pages and images which were simply loaded onto a web server and delivered to any user who requested them. Each time a particular resource was requested, the server responded with the same content. Today's web applications still typically employ a fair number of static resources. However, a large amount of the content that they present to users is generated dynamically. When a user requests a dynamic resource, the server's response is created on the FLY, and each user may receive content that is uniquely customized for him or her. Dynamic content is generated by scripts or other code executing on the server. These scripts are akin to computer programs in their own right. They have US inputs perform processing on these and return their outputs to the user. 52. Chapter 3 Web Application Technologies. When a user's browser requests a dynamic resource, normally it does not simply ask for a copy of that resource. In general, it also submits various parameters along with its request. It is these parameters that enable the server side application to generate content that is tailored to the individual user. HTTP requests can be used to send parameters to the application in three main ways. In the URL query string, in the file path of REST-style URLs, in HTTP cookies, in the body of requests using the post method. In addition to these primary sources of input, the server-side application may, in principle, use any part of the HTTP request as an input to its processing. For example, an application may process the user agent header to generate content that is optimized for the type of browser being used. Like computer software in general, web applications employ a wide range of technologies on the server side to deliver their functionality. Scripting languages such as PHP, VBScript, and Perl. Web application platforms such as ASP.NET and Java. Web servers such as Apache, IIS, and Netscape Enterprise. Databases such as MS SQL, Oracle, and MySQL. Other backend components such as file systems, SOAP-based web services, and directory services. All these technologies and the types of vulnerabilities that can arise in Rela. Tie into them are examined in detail throughout this book. Some of the most common web application platforms and technologies you are likely to encounter are described in the following sections. Common myth. Our applications need only cursory security review because they employ a well-used framework. Use of a well-used framework is often a cause for complacency in web application development, on the assumption that common vulnerabilities such as SQL injection are automatically avoided. This assumption is mistaken for two reasons. First, a large number of web application vulnerabilities arise in an application's design, not its implementation, and are independent of the development framework or language chosen. Chapter 3 Web Application Technologies. 53. Second, because a framework typically employs plugins and packages from the cutting edge of the latest repositories, it is likely that these packages have not undergone security review. Interestingly, if a vulnerability is later found in the application, the same proponents of the myth will readily swap sides and blame their framework or third-party package. The Java Platform. For many years, the Java Platform Enterprise Edition, formerly known as J2EE, was a de facto standard for large-scale enterprise applications. Originally Devil op-ed by Sun Microsystems and now owned by Oracle, it lends itself to multi-tiered and load-balanced architectures and is well-suited to modular development and code reuse. Because of its long history and widespread adoption, many high-quality development tools, application servers, and frameworks are available to assist developers. The Java Platform can be run on several underlying operating systems, including Windows, Linux, and Solaris. Descriptions of Java-based web applications often employ a number of potent, highly confusing terms that you may need to be aware of. An enterprise Java Bean, EJB, is a relatively heavyweight software component that encapsulates the logic of a specified C business function within the application. EJBs are intended to take care of various technical challenges that application developers must address, such as transactional integrity. A plain old Java object, POJO, is an ordinary Java object as distinct from a special object such as an EJB. A POJO normally is used to denote objects that are user-defined and are much simpler and more lightweight than EJBs and those used in other frameworks. A Java servlet is an object that resides on an application server and receives HTTP requests from clients and returns HTTP responses. Servlet implementations can use numerous interfaces to facilitate the development of useful applications. A Java Web Container is a platform or engine that provides a runtime environment for Java-based web applications. Examples of Java Web Containers are Apache Tomcat, BA WebLogic, and JBoss. Many Java web applications employ third-party and open-source components alongside custom-built code. This is an attractive option because it reduces development effort, and Java is well-suited to this modular approach. Here are some examples of components commonly used for key application functions. Authentication, JAS, Assagai. Presentation layer, Site Mesh, Tapestry. 54. Chapter 3 Web Application Technologies. Database Object Relational Mapping, Hibernate. Logging Log4j. If you can determine which open source packages are used in the application you are attacking, you can download these and perform a code review or install them to experiment on. A vulnerability in any of these may be exploitable to compromise the wider application. ASP.NET. ASP.NET is Microsoft's web application framework and is a direct competitor to the Java platform. ASP.NET is several years younger than its counterpart but has made significant inroads into Java's territory. ASP.NET uses Microsoft's .NET framework, which provides a virtual machine, the common language runtime, and a set of powerful APIs, hence ASP.NET. Applications can be written in any .NET language such as C# or VB.NET. ASP.NET lends itself to the event-driven programming paradigm that is normally used in conventional desktop software rather than the script-based approach used in most earlier web application frameworks. This, together with the powerful development tools provided with Visual Studio, makes developing a functional web application extremely easy for anyone with minimal programming skills. The ASP.NET framework helps protect against some common web application vulnerabilities such as cross-site scripting without requiring any effort from the developer. However, one practical downside of its apparent simplicity is that many small-scale ASP.NET applications are actually created by beginners who lack any awareness of the core security problems faced by web applications. PHP. The PHP language emerged from a hobby project. The acronym originally stood for Personal Homepage. It has since evolved almost unrecognizably into a highly powerful and rich framework for developing web applications. It is often used in conjunction with other free technologies in what is known as the LAMP stack, composed of Linux as the operating system, Apache as the web server, MySQL as the database server, and PHP as the programming language for the web application. Numerous open-source applications and components have been developed using PHP. Many of these provide off-the-shelf solutions for common application functions, which are often incorporated into wider custom-built applications. Bulletin boards, PHPBB, PHP Nuke. Administrative frontends, PHP MyAdmin. Chapter 3 Web Application Technologies. 55. Webmail, Squirrel Mail, Aloha Mail. Photo galleries, Gallery. Shopping carts, OS Commerce, ECW Shop. Wikis, MediaWiki, WackaWiki. Because PHP is free and easy to use, it has often been the language of choice for many beginners writing web applications. Furthermore, the design and default configuration of the PHP framework has historically made it easy for programmers to unwittingly introduce security bugs into their code. These factors have meant that applications written in PHP have suffered from a disproportionate number of security vulnerabilities. In addition, several defects have existed within the PHP platform itself that often could be exploited via applications running on it. See Chapter 19 for details on common defects arising in PHP applications. Ruby on Rails. Rails 1.0 was released in 2005 with strong emphasis on model view controller architecture. A key strength of Rails is the breakneck speed with which fully FL-edge data-driven applications can be created. If a developer follows the Rails coding style and naming conventions, Rails can auto-generate a model for database content, controller actions for modifying it, and default views for the application user. As with any highly functional new technology, several vulnerabilities have been found in Ruby on Rails, including the ability to bypass a safe mode analogous to that found in PHP. More details on recent vulnerabilities can be found here. www.ruby-lang.org/own/security. SQL. Structured query language SQL is used to access data in relational databases, such as Oracle, MS SQL Server, and MySQL. The vast majority of today's web applications employ SQL-based databases as their backend data store, and nearly all application functions involve interaction with these data stores in some way. Relational databases store data in tables, each of which contains a number of rows and columns. Each column represents a data file ELD such as name or email address, and each row represents an item with values assigned to some or all of these files. SQL uses queries to perform common tasks such as reading, adding, update, ing, and deleting data. For example, to retrieve a user's email address with a specified name, an application might perform the following query. Select email from users where name equals staff. 56. Chapter 3 Web Application Technologies. To implement the functionality they need, web applications may incorporate user-supplied input into SQL queries that are executed by the backend data base. If this process is not carried out safely, attackers may be able to submit malicious input to interfere with the database and potentially read and write sensitive data. These attacks are described in Chapter 9, along with detailed explanations of the SQL language and how it can be used. XML. Extensible Markup Language, XML, is a specified codon for encoding data in a machine-readable form. Like any markup language, the XML format SEPA breaks a document into content, which is data, and markup, which annotates the data. Markup is primarily represented using tags, which may be start tags, end tags, or empty element tags. Tag name / tag name / e. Start and end tags are paired into elements and may encapsulate document content or child elements. Pet, ginger / pet pets, dog, spot / dog, cat, pause / cat / pets. Tags may include attributes, which are name / value pairs. Data version equals 2.1 pets / data. XML is extensible in that it allows arbitrary tag and attribute names. XML. Documents often include a document type definite-ion DTD, which defines the tags and attributes used in the documents and the ways in which they can be combined. XML and technologies derived from it are used extensively in web applica tie-ins on both the server and client side, as described in later sections of this chapter. Web services. Although this book covers web application hacking, many of the vulnerabilities described are equally applicable to web services. In fact, many applications are essentially a GUI frontend to a set of backend web services. Chapter 3 Web Application Technologies. 57. Web services use Simple Object Access Protocol, SOAP, to exchange data. SOAP typically uses the HTTP protocol to transmit messages and represents data using the XML format. A typical SOAP request is as follows. Post/dotransfer.asp http/1.0 host msecmanager.int.msec.net content type application /SOAP plus XML char set equals UTF 8 content length 891 XML version equals 1.0 SOAP envelope XMLNS SOAP equals http://www.w3.org/2001/12 SOAP envelope SOAP body pre at XMLNS pre equals http://target/list SOAP encoding style equals http://www.w3.org/2001/12/soap-encoding account from account 182810008/from account amount 1430/amount cleared funds false /cleared funds to account 084476656/ to account/pre add /soap body /soap envelope http://www.w3.org/2001/12/soap envelope /www.w3.org/2001/12/soap encoding. In the context of web applications accessed using a browser, you are most likely to encounter SOAP being used by the server-side application to communicate with various backend systems. If user-supplied data is incorporated directly into backend SOAP messages, similar vulnerabilities can arise as for SQL. These issues are described in detail in Chapter 10. If a web application also exposes web services directly, these are also worthy of examination. Even if the front-end application is simply written on top of the web service, differences may exist in input handling and in the functionality exposed by the services themselves. The server normally publishes the available services and parameters using the web services description language WSDL format. Tools such as SOAP UI can be used to create sample requests based on a published WSDL file to call the authentication web service, gain an authentication token, and make any subsequent web service requests. Client-side functionality. For the server-side application to receive user input and actions and present the results to the user, it needs to provide a client-side user interface. Because all web applications are accessed via a web browser, these interfaces all share a 58. Chapter 3 Web Application Technologies. Common core of technologies. However, these have been built upon in various, diverse ways, and the ways in which applications leverage client-side technology has continued to evolve rapidly in recent years. HTML. The core technology used to build web interfaces is hypertext markup language. HTML. Like XML, HTML is a tag-based language that is used to describe the structure of documents that are rendered within the browser. From its simple beginnings as a means of providing basic formatting for text documents, HTML has developed into a rich and powerful language that can be used to create highly complex and functional user interfaces. XHTML is a development of HTML that is based on XML and that has a stricter specified codon than older versions of HTML. Part of the motivation for XHTML was the need to move toward a more rigid standard for HTML markup to avoid The various compromises and security issues that can arise when browsers are obligated to tolerate less strict forms of HTML. More details about HTML and related technologies appear in the following sections. Hyperlinks. A large amount of communication from client to server is driven by the users. Clicking on hyperlinks. In web applications, hyperlinks frequently contain preset request parameters. These are items of data that the user never enters. They are submitted because the server places them into the target URL of the hyperlink that the user clicks. For example, a web application might present a series of links to news stories, each having the following form. A ref equals redir equals /update 29.html what's happening /a. When a user clicks this link, the browser makes the following request. Get /news/8/ redir equals /update 29.html http/1.1 host msec.net. The server receives the redir parameter in the query string and uses its value to determine what content should be presented to the user. Forms. Although hyperlink-based navigation is responsible for a large amount of client to server communications, most web applications need more flexible ways to gather input and receive actions from users. HTML forms are the usual. Chapter 3 Web Application Technologies. 59. Mechanism for allowing users to enter arbitrary input via their browser. A typical form is as follows. Form action equals /secure /login.php, app equals quotations, method equals post, username, input type equals text, name equals username, br, password, input type equals password, name equals password, input type equals hidden, name equals redir, value equals /secure /home.php, input type equals submit, name equals submit, value equals login /form. When the user enters values into the form and clicks the submit button, the browser makes a request like the following. Post /secure /login.php, app equals quotations http/1.1 host, wap.com content type, application /xwww form encoded content length, 39 cookie. SESS equals GTNRPX2 SS2 TSW SENH exchange YG0 LJ47 MXRS JC 6BD. Username equals staff and password equals foo and redir equals /secure /home.php and submit equals log plus in. In this request, several points of interest are reflect how different aspects of the request are used to control server-side processing. Because the HTML form tag contains an attribute specifying the post method, the browser uses this method to submit the form and places the data from the form into the body of the request message. In addition to the two items of data that the user enters, the form contains a hidden parameter redir and a submit parameter submit. Both of these are submitted in the request and may be used by the server-side application to control its logic. The target URL for the form submission contains a preset parameter, app, as in the hyperlink example shown previously. This parameter may be used to control the server-side processing. The request contains a cookie parameter, SESS, which was issued to the browser in an earlier response from the server. This parameter may be used to control the server-side processing. The preceding request contains a header specifying that the type of content in the message body is XWWW form encoded. This means that parameters are represented in the message body as name/value pairs in the same way as they are in the URL query string. The other content type you are likely to encounter when form data is submitted is multipart/form data. An application can request that browsers use multipart encoding by specifying this in an int type attribute in the form tag. With this form of encoding, the content type header in the request also specify ES, a random string that is used as a separator for the 60. Chapter 3 Web Application Technologies. Parameters contained in the request body. For example, if the form specify ed. Multipart encoding, the resulting request would look like the following. Post /secure /login.php, app equals quotations http/1.1 host, wap.com content type, multipart /form data, boundary equals 771385001a content length, 369 cookie, SESS equals GTNRPX2 SS2 TSW SENH exchange YG0 LJ47 MXRS JC 6BD 771385001a. Content disposition, form data, name equals username. DAF 7713850a1a content disposition, form data, name equals password. foo 7713850a1a content disposition, form data, name equals redir. /secure /home.php 771385001a content disposition, form data, name equals submit. Log in 7713850a1a. CSS. Cascading Style Sheets CSS is a language used to describe the presentation of a document written in a markup language. Within web applications, it is used to specify how HTML content should be rendered on screen and in other media, such as the printed page. Modern web standards aim to separate as much as possible the content of a document from its presentation. This separation has numerous benefits TS and CLUD. ING simpler and smaller HTML pages, easier updating of formatting across a website, and improved accessibility. CSS is based on formatting rules that can be defined with different levels of specificity, where multiple rules match an individual document element. Different attributes defined in those rules can cascade through these rules so that the appropriate combination of style attributes is applied to the element. CSS syntax uses selectors to define any class of markup elements to which a given set of attributes should be applied. For example, the following. CSS rule defines the foreground color for headings that are marked up using H2 tags. H2 color, red. Chapter 3 Web Application Technologies. 61. In the earliest days of web application security, CSS was largely overlooked and was considered to have no security implications. Today, CSS is increasingly relevant both as a source of security vulnerabilities in its own right and as a means of delivering effective exploits for other categories of vulnerabilities. See chapters 12 and 13 for more information. JavaScript. Hyperlinks and forms can be used to create a rich user interface that can easily gather most kinds of input that web applications require. However, most apply. Cations employ a more distributed model in which the client side is used not simply to submit user data and actions, but also to perform actual processing of data. This is done for two primary reasons. It can improve the application's performance because certain tasks can be carried out entirely on the client component without needing to make a round trip of request and response to the server. It can enhance usability because parts of the user interface can be dynamically updated in response to user actions without needing to load an entirely new HTML page delivered by the server. JavaScript is a relatively simple but powerful programming language that can be easily used to extend web interfaces in ways that are not possible using HTML alone. It is commonly used to perform the following tasks. Validating user entered data before it is submitted to the server to avoid unnecessary requests if the data contains errors. Dynamically modifying the user interface in response to user actions. 4. Example, to implement drop-down menus and other controls familiar from non-web interfaces. Querying and updating the document object model (DM) within the browser to control the browser's behavior. The browser DM is described in a moment. VBScript. VBScript is an alternative to JavaScript that is supported only in the Internet Explorer browser. It is modeled on Visual Basic and allows interaction with the browser DM, but in general it is somewhat less powerful and developed than JavaScript. Due to its browser-specified C nature, VBScript is scarcely used in today's web applications. Its main interest from a security perspective is as a means of delivering exploits for vulnerabilities such as cross-site scripting in occasional situations where an exploit using JavaScript is not feasible. See Chapter 12. 62. Chapter 3 Web Application Technologies. Document Object Model. The document object model, DM, is an abstract representation of an HTML document that can be queried and manipulated through its API. The DM allows client-side scripts to access individual HTML elements by their ID and to traverse the structure of elements programmatically. Data such as the current URL and cookies can also be read and updated. The DM also includes an event model, allowing code to hook events such as form submission, navigation via links, and keystrokes. Manipulation of the browser DM is a key technique used in Ajax-based applications, as described in the following section. Ajax. Ajax is a collection of programming techniques used on the client side to create user interfaces that aim to mimic the smooth interaction and dynamic behavior of traditional desktop applications. The name originally was an acronym for Asynchronous JavaScript and XML, although in today's web Ajax requests need not be asynchronous and need not employ XML. The earliest web applications were based on complete pages. Each user action, such as clicking a link or submitting a form, initiated a window-level navigation event causing a new page to be loaded from the server. This approach resulted in a disjointed user experience with noticeable delays while large responses were received from the server and the whole page was rendered. With Ajax, some user actions are handled within client-side script code and do not cause a full reload of the page. Instead, the script performs a request in the background and typically receives a much smaller response that is used to dynamically update only part of the user interface. For example, in an Ajax-based shopping application, clicking an Add to Cart button may cause a background request that updates the server-side record of the user's shopping cart and a lightweight response that updates the number of cart items showing on the user screen. Virtually the entire existing page remains unmodified within the browser, providing a much faster and more satisfying experience for the user. The core technology used in Ajax is XML HTTP request. After a certain consolidation of standards, this is now a native JavaScript object that client-side scripts can use to make background requests without requiring a window-level navigation event. Despite its name, XML HTTP request allows arbitrary content to be sent in requests and received in responses. Although many Ajax applications do use XML to format message data, an increasing number have opted to exchange data using other methods of representation. See the next section for one example. Note that although most Ajax applications do use asynchronous communications with the server, this is not essential. In some situations, it may actually make Chapter 3 Web Application Technologies. 63. More sense to prevent user interaction with the application while a particular action is carried out. In these situations, Ajax is still beneficial in providing a more seamless experience by avoiding the need to reload an entire page. Historically, the use of Ajax has introduced some new types of vulnerabilities into web applications. More broadly, it also increases the attack surface of a typical application by introducing more potential targets for attack on both the server and client side. Ajax techniques are also available for use by attack players when they are devising more effective exploits for other vulnerabilities. See chapters 12 and 13 for more details. JSON. JavaScript object notation. JSON is a simple data transfer format that can be used to serialize arbitrary data. It can be processed directly by JavaScript interpreters. It is commonly employed in Ajax applications as an alternative to the XML format originally used for data transmission. In a typical situation, when a user performs an action, client-side JavaScript uses XML HTTP request to communicate the action to the server. The server returns a lightweight response containing data in JSON format. The client-side script then processes this data and updates the user interface accordingly. For example, an Ajax-based webmail application may contain a feature to show the details of a selected contact. When a user clicks a contact, the browser uses XML HTTP request to retrieve the details of the selected contact, which are returned using JSON. The client-side script uses the JavaScript interpreter 041 response and updates the relevant part of the user interface based on its contents. A further location where you may encounter JSON data in today's applications. Applications is as a means of encapsulating data within conventional request parameters. 4. Example, when the user updates the details of a contact, the new information might be communicated to the server using the following request. Post/contacts http/1.0 content type application/xwww former encoded content length 89. Contact equals name, Mike Kemp, ID, 80411486671, email, pikey@clappymonkey.com, and submit equals update@clappymonkey.com. 64. Chapter 3 Web Application Technologies. Same origin policy. The same origin policy is a key mechanism implemented within browsers that is designed to keep content that came from different origins from interfering with each other. Basically, content received from one website is allowed to read and modify other content received from the same site but is not allowed to access content received from other sites. If the same origin policy did not exist and an unwitting user browsed to a malicious website, script code running on that site could access the data and functionality of any other website also visited by the user. This may enable the malicious site to perform funds transfers from the user's online bank, read his or her webmail, or capture credit card details when the user shops online. 4. This reason, browsers implement restrictions to allow this type of interaction only with content that has been received from the same origin. In practice, applying this concept to the details of different web features and technologies leads to various complications and compromises. Here are some key features of the same origin policy that you need to be aware of. A page residing on one domain can cause an arbitrary request to be made to another domain, for example, by submitting a form or loading an image, but it cannot itself process the data returned from that request. A page residing on one domain can load a script from another domain and execute this within its own context. This is because scripts are assumed to contain code rather than data, so cross-domain access should not lead to disclosure of any sensitive information. A page residing on one domain cannot read or modify the cookies or other DM data belonging to another domain. These features can lead to various cross-domain attacks, such as inducing user actions and capturing data. Further complications arise with browser extension technologies, which implement same origin restrictions in different ways. These issues are discussed in detail in Chapter 13. HTML5. HTML5 is a major update to the HTML standard. HTML5 currently is still under development and is only partially implemented within browsers. From a security perspective, HTML5 is primarily of interest for the following reasons. It introduces various new tags, attributes, and APIs that can be leveraged to deliver cross-site scripting and other attacks as described in Chapter 12. Chapter 3 Web Application Technologies. 65. It modifies the core AJAX technology, XML HTTP request, to enable two-way cross-domain interaction in certain situations. This can lead to new cross-domain attacks as described in Chapter 13. It introduces new mechanisms for client-side data storage, which can lead to user privacy issues and new categories of attacks such as client-side SQL injection as described in Chapter 13. Web 2.0. This buzzword has become fashionable in recent years as a rather loose and nebulous name for a range of related trends in web applications, including the following. Heavy use of AJAX for performing asynchronous, behind-the-scenes requests. Increased cross-domain integration using various techniques. Use of new technologies on the client side, including XML, JSON, and Flex. More prominent functionality supporting user-generated content, information sharing, and interaction. As with all changes in technology, these trends present new opportunities for security vulnerabilities to arise. However, they do not define a clear subset of web application security issues in general. The vulnerabilities that occur in these contexts are largely the same as or closely derived from types of vulnerabilities that preceded these trends. In general, talking about Web 2.0 security usually represents a category mistake that does not facilitate clear thinking about the issues that matter. Browser extension technologies. Going beyond the capabilities of JavaScript, some web applications employ browser extension technologies that use custom code to extend the browser's built-in capabilities in arbitrary ways. These components may be deployed as bytecode that is executed by a suitable browser plugin or may involve installing native executables onto the client computer itself. The thick client technologies you are likely to encounter when attacking web applications are Java applets, ActiveX controls, Flash objects, Silverlight objects. These technologies are described in detail in Chapter 5. 66. Chapter 3 Web Application Technologies. State and sessions. The technologies described so far enable the server and client components of a web application to exchange and process data in numerous ways. To implement most kinds of useful functionality, however, applications need to track the state of each user's interaction with the application across multiple requests. 4. Example, a shopping application may allow users to browse a product catalog, add items to a cart, view and update the cart contents, proceed to checkout, and provide personal and payment details. To make this kind of functionality possible, the application must maintain a set of stateful data generated by the user's actions across several requests. This data normally is held within a server-side structure called a session. When a user performs an action, such as adding an item to her shopping cart, the server-side application updates the relevant details within the user's session. When the user later views the contents of her cart, data from the session is used to return the correct information to the user. In some applications, state information is stored on the client component rather than the server. The current set of data is passed to the client in each server response and is sent back to the server in each client request. Of course, because the user may modify any data transmitted via the client component, applications need to protect themselves from attackers who may change this state information in an attempt to interfere with the application's logic. The ASP.NET platform makes use of a hidden form phi ELD called viewState to store state information about the user's web interface and thereby reduce overhead on the server. By default, the contents of the viewState include a keyed hash to prevent tampering. Because the HTTP protocol is itself stateless, most applications need a way to re-identify individual users across multiple requests for the correct set of state data to be used to process each request. Normally, this is achieved by issuing each user a token that uniquely identifies that user session. These tokens may be transmitted using any type of request parameter, but most applications use HTTP cookies. Several kinds of vulnerabilities arise in relation to session handling, as described in detail in Chapter 7. Encoding schemes. Web applications employ several different encoding schemes for their data. Both the HTTP protocol and the HTML language are historically text-based and different encoding schemes have been devised to ensure that these mechanisms can safely handle unusual characters and binary data. When you are attacking A web application, you will frequently need to encode data using a relevant. Chapter 3 Web Application Technologies. 67. Scheme to ensure that it is handled in the way you intend. Furthermore, in many cases you may be able to manipulate the encoding schemes an application uses to cause behavior that its designers did not intend. URL encoding. URLs are permitted to contain only the printable characters in the US ASCII character set, that is, those whose ASCII code is in the range 0x20 to 0x7e. Inclusive. Furthermore, several characters within this range are restricted because they have special meaning within the URL scheme itself or within the HTTP protocol. The URL encoding scheme is used to encode any problematic characters within the extended ASCII character set so that they can be safely transported over HTTP. The URL encoded form of any character is the %prefix x followed by the character's 2-digit ASCII code expressed in hexadecimal. Here are some characters that are commonly URL encoded. %3d equals %25%, %20 space, %0a new line, %00 null byte. A further encoding to be aware of is the plus character, which represents a URL encoded space in addition to the %20 representation of a space. Note: for the purpose of attacking web applications, you should URL encode any of the following characters when you insert them as data into an HTTP request. Space %, and equals plus hashtag. Of course, you will often need to use these characters with their special meaning when modifying a request, for example, to add a request parameter to the query string. In this case, they should be used in their literal form. Unicode encoding. Unicode is a character encoding standard that is designed to support all of the world's writing systems. It employs various encoding schemes, some of which can be used to represent unusual characters in web applications. 16-bit Unicode encoding works in a similar way to URL encoding. 4. Transmission over HTTP. The 16-bit Unicode encoded form of a character is 68. Chapter 3 Web Application Technologies. The %u prefix x followed by the character's Unicode code point expressed in hexadecimal. %u2215 slash %u00e9a. UTF-8 is a variable length encoding standard that employs one or more bytes to express each character. For transmission over HTTP, the UTF-8 encoded form of a multi-byte character simply uses each byte expressed in hexadecimal and preceded by the %prefix x. %c 2%a9 copyright. %e 2%89% a0. For the purpose of attacking web applications, Unicode encoding is primarily of interest because it can sometimes be used to defeat input validation mechanisms. If an input fileter blocks certain malicious expressions but the component that subsequently processes the input understands Unicode encoding, it may be possible to bypass the fileter using various standard and malformed Unicode encodings. HTML encoding. HTML encoding is used to represent problematic characters so that they can be safely incorporated into an HTML document. Various characters have special meaning as metacharacters within HTML and are used to defeat any documents structure rather than its content. To use these characters safely as part of the document's content, it is necessary to HTML encode them. HTML encoding defines numerous HTML entities to represent specify see literal characters. End quote. And oppose. And amp and LT. And GT. In addition, any character can be HTML encoded using its ASCII code in decimal form. And hashtag 34. And hashtag 39, or by using its ASCII code in hexadecimal form, prefix xd by an x. Chapter 3 Web Application Technologies. 69. And hashtag x22. And hashtag x27. When you are attacking a web application, your main interest in HTML encoding is likely to be when probing for cross-site scripting vulnerabilities. If an application returns user input unmodified and within its responses, it is probably vulnerable, whereas if dangerous characters are HTML encoded, it may be safe. See Chapter 12 for more details on these vulnerabilities. Base 64 encoding. Base 64 encoding allows any binary data to be safely represented using only printable ASCII characters. It is commonly used to encode email attachments. For safe transmission over SMTP, it is also used to encode user credentials in basic HTTP authentication. Base 64 encoding processes input data in blocks of 3 bytes. Each of these blocks is divided into 4 chunks of 6 bits each. 6 bits of data allows for 64 different possible permutations, so each chunk can be represented using a set of 64 characters. Base 64 encoding employs the following character set, which contains only printable ASCII characters. A B C D E F G H I J K L M N O P Q R S T U V W X Y Z Dif Gitgul Naprstu Vuxes 0 1 2 3 4 5 6 7 8 9 plus slash. If the phi NAL block of input data results in fewer than 3 chunks of output data, the output is padded with 1 or 2 equals characters. For example, here's the base 64 encoded form of the Web Application Hacker's Handbook. VGHLIFDLEBBCHBSAWNHD5BIYW5 Kim 9 VA equals. Many web applications use base 64 encoding to transmit binary data within cookies and other parameters, and even to obfuscate, that is, to hide sensitive data to prevent trivial modify cation. You should always look out for and decode any base 64 data that is issued to the client. Base 64 encoded strings can often be easily recognized by their specify C character set in the presence of padding characters at the end of the string. Hex encoding. Many applications use straightforward hexadecimal encoding when transmitting binary data using ASCII characters to represent the hexadecimal block. For example, hex encoding the username DAF within a cookie would result in this. 646,166. 70. Chapter 3 Web Application Technologies. As with base 64, hex encoded data is usually easy to spot. You should always attempt to decode any such data that the server sends to the client to understand its function. Remoting and serialization frameworks. In recent years, various frameworks have evolved for creating user interfaces in which client-side code can remotely access various programmatic APIs implemented on the server side. This allows developers to partly abstract away from the distributed nature of web applications and write code in a manner that is closer to the paradigm of a conventional desktop application. These frameworks typically provide stub APIs for use on the client side. They also automatically handle both the remoting of these API calls to the relevant server-side functions and the serialization of any data that is passed to those functions. Examples of these kinds of remoting and serialization frameworks include the following: Flex and AMF, Silverlight and WCF, Java serialized objects. We will discuss techniques for working with these frameworks and the kinds of security issues that can arise in chapters 4 and 5. Next steps. So far, we have described the current state of web application in Security Exam and the core mechanisms by which web applications can defend themselves, and taken a brief look at the key technologies employed in today's applications. With this groundwork in place, we are now in a position to start looking at the actual practicalities of attacking web applications. In any attack, your FIRST task is to map the target application's content and functionality to establish how it functions, how it attempts to defend itself, and what technologies it uses. The next chapter examines this mapping process in detail and shows how you can use it to obtain a deep understanding of an application's attack surface. This knowledge will prove vital when it comes to finding and exploiting security FLAWS within your target. Chapter 3 Web Application Technologies. 71. Questions. Answers can be found asked//msec.net/wa. 1. What is the options method used for? 2. What are the if-modified since and if num-match headers used for? Why might you be interested in these when attacking an application? 3. What is the signify cans of the secure flag when a server sets a cookie? 4. What is the difference between the common status codes 301 and 302? 5. How does a browser interoperate with a web proxy when SSL is being used? Chapter 4. Mapping the application. The FIRST step in the process of attacking an application is gathering and examine some key information about it to gain a better understanding of what you are up against. The mapping exercise begins by enumerating the application's content and functionality in order to understand what the application does and how it behaves. Much of this functionality is easy to identify, but some of it may be hidden, requiring a degree of guesswork and luck to discover. After a catalog of the application's functionality has been assembled, the principal task is to closely examine every aspect of its behavior, its core SECU, writing mechanisms, and the technologies being employed on both the client and server. This will enable you to identify the key attack surface that the application exposes and hence the most interesting areas where you should target subs. Quint probing to find exploitable vulnerabilities. Often the analysis exercise can uncover vulnerabilities by itself, as discussed later in the chapter. As applications get ever larger and more functional, effective mapping is a valuable skill. A seasoned expert can quickly triage whole areas of functionality, looking for classes of vulnerabilities as opposed to instances while investing. Signify can time and testing other specify C areas, aiming to uncover a high-risk issue. This chapter describes the practical steps you need to follow during application mapping, various techniques and tricks you can use to maximize its effectiveness, and some tools that can assist you in the process. 73. 74. Chapter 4 Mapping the application. Enumerating content and functionality. In a typical application, the majority of the content and functionality can be identified via manual browsing. The basic approach is to walk through the application starting from the main initial page, following every link, and navigating through all multi-stage functions, such as user registration or password resetting. If the application contains a sitemap, this can provide a useful starting point for enumerating content. However, to perform a rigorous inspection of the enumerated content and to obtain a comprehensive record of everything identified, you must employ more advanced techniques than simple browsing. Web spidering. Various tools can perform automated spidering of websites. These tools work by requesting a web page, parsing it for links to other content, requesting these links, and continuing recursively until no new content is discovered. Building on this basic function, web application spiders attempt to achieve a higher level of coverage by also parsing HTML forms and submitting these back to the application using various preset or random values. This can enable them to walk through multi-stage functionality and to follow forms-based navigation, such as where drop-down lists are used as content menus. Some tools also parse client-side JavaScript to extract URLs pointing to further content. Numerous free tools are available that do a decent job of enumerating applica tie-in content and functionality, including Burp Suite, WebScarab, Zetattack, Proxy, and Cat. See Chapter 20 for more details. Tip: many web servers contain a file named robots.txt in the web root that contains a list of URLs that the site does not want web spiders to visit or search engines to index. Sometimes this file contains references to sensitive functionality which you are certainly interested in spidering. Some spidering tools designed for attacking web applications check for the robots.txt file and use all URLs within it as seeds in the spidering process. In this case, the robots.txt file may be counterproductive to the security of the web application. This chapter uses a FI-Tino application, Extreme Internet Shopping EIS, to provide examples of common application mapping actions. Figure 4.1 shows Burp Spider running against EIS. Without logging on, it is possible to map out the /shop directory and 2 news articles in the /media directory. Also note that the robots.txt file is shown in the file references the directories /msic portal and /site old. These are not linked from anywhere in the application and would not be indexed by a web spider that only followed links from published content. Tip: applications that employ REST-style URLs use portions of the URL file loop path to uniquely identify data and other resources used within the application. Chapter 4 Mapping the application. 75. See Chapter 3 for more details. The traditional web spider's URL-based view of the application is useful in these situations. In the EIS application, the /shop and /pub paths employ REST-style URLs, and spidering these areas easily provides unique links to the items available within these paths. Figure 4.1 Mapping part of an application using Burp Spider. Although it can often be effective, this kind of fully automated approach to content enumeration has some signify can't limitations. Unusual navigation mechanisms such as menus dynamically created and handled using complicated JavaScript code often are not handled properly by these tools, so they may miss whole areas of an application. Links buried within compiled client-side objects such as Flash or Java applets may not be picked up by a spider. Multi-stage functionality often implements fine-grained input validation checks which do not accept the values that may be submitted by an automated tool. For example, a user registration form may contain files for name, email address, telephone number, and zip code. An automated. 76. Chapter 4 Mapping the application. Application spider typically submits a single test string in each editable form file ELD, and the application returns an error message saying that one or more of the items submitted were invalid. Because the spider is not intelligent enough to understand and act on this message, it does not proceed past the registration form and therefore does not discover any more content or functions accessible beyond it. Automated spiders typically use URLs as identifiers of unique content. To avoid continuing spidering indefinitely, they recognize when linked content has already been requested and do not request it again. However, many applications use forms-based navigation in which the same URL may return very different content and functions. For example, a banking application may implement every user action via a post request to /account.jsp and use parameters to communicate the action being performed. If a spider refuses to make multiple requests to this URL, it will miss most of the application's content. Some application spiders attempt to handle this situation. For example, Burp Spider can be configured to individuate form submissions based on parameter names and values. However, there may still be situations where a fully automated approach is not completely effective. We discuss approaches to mapping this kind of functionality later in this chapter. Conversely to the previous point, some applications place volatile data within URLs that is not actually used to identify resources or functions for example, parameters containing timers or random number seeds. Each page of the application may contain what appears to be a new set of URLs that the spider must request, causing it to continue running indefinitely. Where an application uses authentication, an effective application spider must be able to handle this to access the functionality that the authentication protects. The spiders mentioned previously can achieve this by manually configuring the spider either with a token for an authenticated session or with credentials to submit to the login function. However, even when this is done, it is common to find that the spider's operation breaks the authenticated session for various reasons. By following all URLs, at some point the spider will request the logout function, causing its session to break. If the spider submits invalid input to a sensitive function, the application may defensively terminate the session. If the application uses per page tokens, the spider almost certainly will fail to handle these properly by requesting pages out of their expected sequence, probably causing the entire session to be terminated. Chapter 4, Mapping the application. 77. Warning: in some applications, running even a simple web spider that parses in request links can be extremely dangerous. For example, an application may contain administrative functionality that deletes users, shuts down a database, restarts the server, and the like. If an application-aware spider is used, great damage can be done if the spider discovers and uses sensitive functionality. The authors have encountered an application that included some content management system (CMS) functionality for editing the content of the main application. This functionality could be discovered via the sitemap and was not protected by any access control. If an automated spider were run against the site, it would find the edit function and begin sending arbitrary data, resulting in the main websites being defaced in real time while the spider was running. User-directed spidering. This is a more sophisticated and controlled technique that is usually able to automated spidering. Here, the user walks through the application in the normal way using a standard browser, attempting to navigate through all the application's functionality. As he does so, the resulting traffic is passed through a tool combining an intercepting proxy and spider which monitors all requests and responses. The tool builds a map of the application in corpo, rating all the URLs visited by the browser. It also parses all the application's responses in the same way as a normal application-aware spider and updates the sitemap with the content and functionality it discovers. The spiders within Burp Suite and WebScarab can be used in this way. See Chapter 20 for more information. Compared with the basic spidering approach, this technique offers numerous benefits. Where the application uses unusual or complex mechanisms for navigation, the user can follow these using a browser in the normal way. Any functions and content accessed by the user are processed by the proxy/spider tool. The user controls all data submitted to the application and can ensure that data validation requirements are met. The user can log into the application in the usual way and ensure that the authenticated session remains active throughout the mapping process. If any action performed results in session termination, the user can log in again and continue browsing. Any dangerous functionality such as delete user.jsp is fully enumerated and incorporated into the proxy sitemap because links to it will be parsed out of the application's responses, but the user can use discretion in deciding which functions to actually request or carry out. 78. Chapter 4, Mapping the application. In the extreme internet shopping site, previously it was impossible for the spider to index any content within /home because this content is authenticated. Requests to /home result in this response. http://1.1302 move temporarily date, Monday, January 24th, 2011, 16:13 and 12 seconds Greenwich Mean Time server, Apache location /auth/login, return URL equals /home/. With user-directed spidering, the user can simply log into the application using her browser, and the proxy/spider tool picks up the resulting session and identify all the additional content now available to the user. Figure 4.2 shows the EIS sitemap when the user has successfully authenticated to the protected areas of the application. Figure 4.2, Burp sitemap after user-guided spidering has been performed. This reveals some additional resources within the home menu system. The IGear shows a reference to a private profile that is accessed through a JavaScript function launched with the onClick event handler. A ref equals #onClick equals UI_nav profile private profile /a. Chapter 4, Mapping the application. 79. A conventional web spider that simply follows links within HTML is likely to miss this type of link. Even the most advanced automated application crawlers lag way behind the numerous navigational mechanisms employed by today's applications and browser extensions. With user-directed spidering, however, the user simply needs to follow the visible on-screen link using her browser, and the proxy/spider tool adds the resulting content to the sitemap. Conversely, note that the spider has successfully identified the link to Chore sites that's contained in an HTML comment, even though this link is not shown on screen to the user. Tip: in addition to the proxy/spider tools just described, another range of tools that are often useful during application mapping are the various browser extensions that can perform HTTP and HTML analysis from within the browser interface. For example, the IE Watch tool shown in Figure 4.3, which runs within Microsoft Internet Explorer, monitors all details of requests and responses, including headers, request parameters, and cookies. It analyzes every application page to display links, scripts, forms, and thick client components. Of course, all this information can be viewed in your intercepting proxy, but having a second record of useful mapping data can only help you better understand the application and enumerate all its functionality. See Chapter 20 for more information about tools of this kind. Figure 4.3, IE Watch performing HTTP and HTML analysis from within the browser. 80. Chapter 4, Mapping the application hack. Steps 1. Configure your browser to use either Burp or WebScarab as a local proxy. See Chapter 20 for specific details about how to do this if you're unsure. 2. Browse the entire application normally, attempting to visit every link/URL you discover, submitting every form, and proceeding through all multi-step functions to completion. Try browsing with JavaScript enabled and disabled, and with cookies enabled and disabled. Many applications can handle various browser configurations, and you may reach different content and code paths within the application. 3. Review the sitemap generated by the proxy/spider tool, and identify any application content or functions that you did not browse manually. Establish how the spider enumerated each item. For example, in Burp Spider, check the link from details. Using your browser, access the item manually so that the response from the server is parsed by the proxy/SPI tool to identify any further content. Continue this step recursively until No further content or functionality is identified. For optionally, tell the tool to actively spider the site using all of the already enumerated content as a starting point. To do this, first identify any URLs that are dangerous or likely to break the application session and configure the spider to exclude these from its scope. Run the spider and review the results for any additional content it discovers. The sitemap generated by the proxy/spider tool contains a wealth of information about the target application, which will be useful later in identifying the various attack surfaces exposed by the application. Discovering hidden content. It is common for applications to contain content and functionality that is not directly linked to or reachable from the main visible content. A common example is functionality that has been implemented for testing or debugging purposes and has never been removed. Another example arises when the application presents different functionality to different categories of users, for example, anonymous users, authenticated regular users, and administrators. Users at one privilege level who perform exhaustive spidering of the application may miss functionality that is visible to users at other levels. An attacker who discovers the functionality may be able to exploit it to elevate her privileges within the application. There are countless other cases in which interesting content and functionality may exist that the mapping techniques previously described would not identify. Backup copies of live file s. In the case of dynamic pages, their file extension may have changed to one that is not mapped as executable, enabling you. Chapter 4, Mapping the application. 81. To review the page source for vulnerabilities that can then be exploited on the live page. Backup archives that contain a full snapshot of file s within or indeed outside the web root, possibly enabling you to easily identify all content and functionality within the application. New functionality that has been deployed to the server for testing but not yet linked from the main application. Default application functionality in an off-the-shelf application that has been superficially hidden from the user but is still present on the server. Old versions of file s that have not been removed from the server. In the case of dynamic pages, these may contain vulnerabilities that have been IXED in the current version but that can still be exploited in the old version. Configuration and include file s containing sensitive data such as database credentials. Source file s from which the live application's functionality has been compiled. Comments in source code that in extreme cases may contain information, such as usernames and passwords, but that more likely provide information about the state of the application. Key phrases such as test this function or something similar are strong indicators of where to start hunting for vulnerabilities. Log file s that may contain sensitive information such as valid usernames, session tokens, URLs visited, and actions performed. Effective discovery of hidden content requires a combination of automated and manual techniques and often relies on a degree of luck. Brute force techniques. Chapter 14 describes how automated techniques can be leveraged to speed up just about any attack against an application. In the present context of Informa time gathering, automation can be used to make huge numbers of requests to the web server attempting to guess the names or identify errors of hidden functionality. For example, suppose that your user-directed spidering has identified the following application content. http://eis/auth/login http://eis/auth/forgot password http://eis/home http://eis/pub/media/100/view http://eis/images/eis.gif http://eis/include/eis.css. 82. Chapter 4, Mapping the application. The FIRST step in an automated effort to identify hidden content might involve the following requests to locate additional directories. http://eis/about http://eis/abstract http://eis/academics http://eis/accessibility http://eis/accounts http://eis/action. Burp Intruder can be used to iterate through a list of common directory names and capture details of the server's responses, which can be reviewed to identify valid directories. Figure 4 shows Burp Intruder being configured to probe for common directories residing at the web root. Figure 4 Burp Intruder being configured to probe for common directories. When the attack has been executed, clicking column headers such as status and length sorts the results accordingly, enabling you to quickly identify a list of potential further resources as shown in Figure 4-5. Having brute force for directories and subdirectories, you may then want to find additional pages in the application. Of particular interest is the /auth directory containing the login resource identified during the spidering process, which is likely to be a good starting point for an unauthenticated attacker. Again, you can request a series of file s within this directory. Chapter 4, Mapping the application. 83. http://eis/auth/about http://eis/auth/about us http://eis/auth/adduzea http://eis/auth/admin http://eis/auth/administration http://eis/auth/admins. Figure 4-5, Burp Intruder showing the results of a directory brute force attack. Figure 4-6 shows the results of this attack, which has identified several resources within the /auth directory. Login logout register profile. Note that the request for profile returns the HTTP status code 302. This indicates that accessing this link without authentication redirects the user to the login page. Of further interest is that although the login page was discovered during spidering, the register page was not. It could be that this extra functionality is operational, and an attacker could register a user account on the site. 84. Chapter 4, Mapping the application. Figure 4-6, Burp Intruder showing the results of a file brute force attack. Note: do not assume that the application will respond with 200 OK if a requested resource exists and 404 not found if it does not. Many applications handle requests for non-existent resources in a customized way, often returning a bespoke error message and a 200 response code. Furthermore, some requests for existent resources may receive a non-200 response. The following is a rough guide to the likely meaning of the response codes that you may encounter during a brute force exercise looking for hidden content. 302 found. If the redirect is to a login page, the resource may be accessible only by authenticated users. If the redirect is to an error message, this may indicate a different reason. If it is to another location, the redirect may be part of the application's intended logic, and this should be investigated further. 400 bad request. The application may use a custom naming scheme for directories and file s within URLs, which a particular request has not complied with. More likely, however, is that the word list you are using contains some whitespace characters or other invalid syntax. 401 unauthorized or 403 forbidden. This usually indicates that the requested resource exists but may not be accessed by any user. Chapter 4, Mapping the application. 85. regardless of authentication status or privilege level. It often occurs when directories are requested, and you may infer that the directory exists. 500 internal server error. During content discovery, this usually indicates that the application expects certain parameters to be submitted when requesting the resource. The various possible responses that may indicate the presence of interesting content mean that it's difficult to write a fully automated script to output a listing of valid resources. The best approach is to capture as much information as possible about the application's responses during the brute force exercise and manually review it. Hack steps. 1. 2. Make some manual requests for known valid and invalid resources and identify how the server handles the latter. Use the sitemap generated through user-directed spidering as a basis for automated discovery of hidden content. 3. Make automated requests for common file names and directories within each directory or path known to exist within the application. Use burp intruder or custom script, together with word lists of common files and directories, to quickly generate large numbers of requests. If you have identified a particular way in which the application handles requests for invalid resources, such as a customized, file not found page, configure intruder, or your script to highlight these results so that they can be ignored. 4. Capture the responses received from the server and manually review them to identify valid resources. 5. Perform the exercise recursively as new content is discovered. Inference from published content. Most applications employ some kind of naming scheme for their content and functionality. By inferring from the resources already identified within the application, it is possible to fine-tune your automated enumeration exercise to increase the likelihood of discovering further hidden content. In the EIS application, note that all resources in /auth start with a capital letter. This is why the word list used in the file brute forcing in the previous section was deliberately capitalized. Furthermore, since we have already identified a page called forgot password in the /auth directory, we can search for similarly named items such as the following: http://eis/auth/reset password. 86. Chapter 4, mapping the application. Additionally, the sitemap created during user-directed spidering identified these resources. http://eis/pub/media/100 http://eis/pub/media/117 http://eis/pub/user/11. Other numeric values in a similar range are likely to identify further resources and information. Tip burp intruder is highly customizable and can be used to target any portion of an HTTP request. Figure 4.7 shows burp intruder being used to perform a brute force attack on the FIRST half of a file name to make the requests. http://eis/auth/add password http://eis/auth/forgot password http://eis/auth/get password http://eis/auth/reset password http://eis/auth/retrieve password http://eis/auth/update password. Figure 4.7. Burp intruder being used to perform a customized brute force attack on part of a file name. Chapter 4, mapping the application. 87. Hack steps. 1, 2, 3, 4. Review the results of your user-directed browsing and basic brute force exercises. Compile lists of the names of all enumerated subdirectories, file stems, and file extensions. Review these lists to identify any naming schemes in use. For example, if there are pages called add-document.jsp and view-document.jsp, there may also be pages called edit-document.jsp and remove-document.jsp. You can often get a feel for developers' naming habits just by reading a few examples. For example, depending on their personal style, developers may be verbose, add a new user.asp, succinct, add user.asp, use abbreviations, add usr.asp, or even be more cryptic, add u.asp. Getting a feel for the naming styles in use may help you guess the precise names of content you have not already identified. Sometimes the naming scheme used for different content employs identifiers such as numbers and dates, which can make inferring hidden content easy. This is most commonly encountered in the names of static resources rather than dynamic scripts. For example, if a company's website links to Annual Report 2009.pdf and Annual Report 2010.pdf, it should be a short step to identifying what the next report will be called. Somewhat incredibly, there have been notorious cases of companies placing files containing financial reports on their web servers before they were publicly announced, only to have wily journalists discover them based on the naming scheme used in earlier years. Review all client-side code such as HTML and JavaScript to identify any clues about hidden server-side content. These may include HTML comments related to protected or unlinked functions, HTML forms with disabled submit elements, and the like. Often, comments are automatically generated by the software that has been used to generate web content, or by the platform on which the application is running. References to items such as server-side include files are of particular interest. These files may actually be publicly downloadable and may contain highly sensitive information such as database connection strings and passwords. In other cases, developers' comments may contain all kinds of useful tidbits such as database names, references to backend components, SQL query strings, and so on. Thick client components such as Java applets and ActiveX controls may also contain sensitive data that you can extract. See Chapter 15 for more ways in which the application may disclose Informa. Tie-in about itself. Continued. 88 Chapter 4, mapping the application. 5. Add to the list of enumerated items any further potential names conjectured on the basis of the items that you have discovered. Also add to the file extension list common extensions such as txd, bawk, src, inc, and old, which may uncover the source to backup versions of live pages. Also add extensions associated with the development languages in use, such as .java and .cs, which may uncover source files that have been compiled into live pages. See the tips